guys, once again welcome to YouTube channel Skill Tech, and today we will cover an important topic that is Introduction to Industrial Mathematics. I am referring this tutorial from a journal, that is International Journal of Technical Research and Science, which I found on Google. So I will read from here. So very interesting journal, and if you belong to this industrial mathematics, it is very good for you. So let's go. What is it? So if you see here, there is no question that mathematics has played a leading role in the development of physics and engineering through the last century. Okay, it has a great role. So however, the direct participation of mathematics in solving the problems of industry is the new trend, so-called industrial mathematics. Industrial mathematics has developed a new profession in this report. We'll talk about it. So first we will go through the introduction of industrial mathematics. So mathematics is one of the oldest and fundamental sciences the world. Mathematics has been derived from the Greek word mathema, meaning knowledge, study, learning. It has no generally accepted definition but deals with logical reasoning and quantitative calculation. So mathematicians is a person who uses the exclusive knowledge of mathematics in their work. The education of mathematician focuses on mathematics itself as a way to understand the relationship between abstract objects. Some mathematicians explore theories while others apply them to solve daily problems. They try to be as precise and concise as they could while solving a problem. When asked to solve a problem, usually a person will think of the ways they know that they can be applied to solve the problem and would back off if he is unable to find such a way. But a mathematician will abstract the problem into a mathematical problem and apply mathematical abilities to solve it. If he is successful in solving the problem, he rethinks of the models and takes a different approach. He continues until he is successful in finding the solution. Modern mathematics is broadly divided into pure mathematics and applied mathematics. What is pure and applied? The difference between the two is based on their application. Pure mathematics is a branch of mathematics that is studied and principles are developed for the sake of mathematics rather than their immediate use. In other words, it's based on number theory. Fibonacci series is an example of this, which has almost no significant use to mankind. On the contrary, applied mathematics is a branch of mathematics that is involved in the study of physical and biological world, that is studied purely for application purposes. It is based on numerical methods having extensive use in computer science and engineering. Now, second one is industrial mathematics. So mathematics is the most versatile of all the sciences. It is uniquely well placed to respond to the demands of a rapidly changing economic landscape. Unfortunately, academic mathematics is insufficiently connected to mathematics used in industries, making it difficult to build closer connection to industry. Hence, academic mathematical science must strike a better balance between theory and applications. Okay, so industrial mathematics is a new research field of mathematics which deals with the use of mathematical modeling to solve industrial problems, thereby serving as a foundation for developing future technology. It comprises of a mixture of pure applied mathematical modeling such as partial differential equations, probability, statistics, discrete mathematics, and many more. In other words, it will integrate and reorganize pure and applied mathematics into a volatile form so as to respond to the needs of industrial technologies. Let us consider a case study of a Mexican company who had complained regarding the noise from the car seat air can fan blowers. They were having a great loss as their products were returned stating about an undesirable noise. They did not clearly understand what kind of noise was undesirable. Many analyses were made, but the noise considered undesirable by the Mexican manufacturing plant was different to what the client plant considered to be. This is where mathematics rescued them. They measured the noise frequency spectrum with the special microphone and computer, investigated which frequencies were annoying to human hearing, statistically analyzed the noise spectrum and revealed which frequency bands were undesirable from the viewpoint of the client company. They then wrote a computer script that could automatically determine if an item is defective or not. This was one of the incidents when industry benefited from the work of mathematicians. It is evident from the above case study that ability to effectively use mathematical modeling, simulation, control and optimization will be the foundation for technological and economic development, helping in achieving better understanding of industrial models and processes. So the idea of construction and analysis model and industrial mathematics. So the use of concepts and methods of mathematics as an aid to understand real world problems arising from diverse fields in physics, life, social sciences is now a well established approach to gain frontier knowledge in the area. We believe that one of the most important contributions that mathematics makes in the study of such complex situations and problems is through the novel idea of construction and analysis of models. A more holistic approach as compared to mere custom-made black box modeling methodology of prevalent industrial R&D. Any model can be defined as a simplified representation of certain aspects of real-world system or problem. A mathematical model is a model created in the abstract world using mathematical concept and manipulation of the model via mathematical theories and techniques or computer-aided numerical computations would provide the necessary mathematical solution. The solutions are then physically interpreted and strenuously validated. The real world is re-entered by translating these theoretical solutions into practical solutions to the original real problems and later put to further application in the form of useful predictions. Alternatively, we could propound a statistical model instead after gathering much data from real life problems. The corresponding cycle of idea then follows suit. The same applies to any man-made real engineering and industrial problems. Any model can be defined as a simplified representation of certain aspect of these real man-made systems. So if you see here real world problem system, simplify real model, abstract mathematical statistical model, then it's a program, then computational model, and then conclusion, and then again interpret and validation to real world system, then real world system predictions. And from this mathematical statistical model, both directional theory and mathematics, analyze and solve. So this is construction and analysis models. To increase the awareness on the appreciation for the effectiveness of the application of mathematics, statistics, and computational procedure to solve real industrial problems of a non-textbook nature, the field of industrial mathematics is introduced. The word industrial is used to include corporation, business firms, and government agencies. As we have stated earlier, the notable nature of this brand of mathematics can be brought to fore through the cycle of approach of construction and analysis of models. As entrenched in figure, many are of the opinion that this trademark of industrial mathematics would stimulate greater awareness in the wider community of power of mathematics in providing solution path to real world problems. So means of interaction between mathematics and industry, how they interact. So problem in this industry which benefit significantly from mathematics are seen on different scales. Specific problems where the current methods or commercial codes fail, where a new feature has to be included, where current model do not meet the requirement. Second, medium scale problems where the transfer of new technology, algorithm approach, or such has to be performed, or where a new mathematical software product has to be brought into market. This is very often done via companies and then spun out of a research lab or an academic institution. These mathematical spin-off shows a high survival rate in the market or are brought out by global players, thus creating novel high-tech jobs with high salaries. These kinds of projects typically require 3 to 6% years. Large scale multi-physics, multi-scale, multi-mathematics are problems where different physical models are coupled, where different areas of mathematics are used, and where they are essentially no methods available. Such products can have an order of 20 to 30% years. Fifth one, mathematical areas and industrial applications. Industrial mathematics has not only been useful for solving industrial problems in better way, but it has also been used to check design before manufacture, to test plans before construction, and to explain the occurrence of faults in the process, if any, helping the companies to have calculated risk. The following table gives a view of association between areas of mathematics and applications. So, mathematical area and application area. Algebra in number theory, cryptography, computational fluid dynamics, aircraft and automobile design. Differential equations, aerodynamics, porous media, finance. Discrete mathematics, communication and information security. Formal system and logic, computer security verification. Geometry, computer aided engineering and design. No linear control. Operation of mechanical and electrical system. Numerical analysis, essentially all applications. Optimization, asset allocation, shape and system design. Stochastic process, signal analysis. Parallel algorithms, weather modeling and prediction, crash simulation. Statistics, design of experiments, analysis of large data sets. So, industrial mathematics is an interdisciplinary field. In other words, it not only focuses on mathematics but also on other fields such as business, computer science, engineering, etc. Since mathematics is the foundation of many other subjects, a number of workers using mathematical techniques like engineers, computer scientists, economists, etc., is greater than number of formally designated mathematicians like statistician, research analysts, etc. In other words, applied mathematicians collaborate with other workers to achieve common solution to problems. So now we will see the conclusion. With the rapid development of science and technology, modern manufacturing and service industries have changed drastically. Industrial mathematics is the main factor in realizing and implementing sophisticated methods, large database, inexpensive computing, etc. to meet the new demand. Also, industrial mathematicians collaborate with workers from different fields to produce innovative products. As flow of ideas run strongly in both directions, but building and maintaining work relationship between industry and academics is not emphasized. So, non-academic mathematicians should be encouraged to enhance research, teaching, application throughout mathematics, science, industry, and engineering to not only increase the range of real-world problems but also enhance the positive impact on society. So I hope this journal would be very helpful to you. So I hope you like this topic of industrial mathematics, how this mathematics branch is revolutionizing the industry in many ways, and in the coming future it will revolutionize it at a rapid speed. Thank you so much for watching this video.